Hello students, today we are going to start from question number 10. This is one of the important concept of permutation where we are going to deal some different kind of questions. So here the questions are given, basically the questions will be of that kind where one word is given to us. With the help of that word we are framing some other words, means the letters are given in that word, we are going to make some other words also. That words may be meaningful, may not be meaningful, okay, but here that word will have one special thing, that word will contain some repeating letters. For example, you can see the word given to us over here, that is given as Mississippi. As you can see, this particular word we are talking about, okay, this kind of words will be given to you. So in this word you observe some letters are repeating. For example, letter P is repeating 2 times, letter I and letter S are repeating 4 times respectively. So if we want to form some another words with the help of the letter given in this word, then one thing is different from the previous questions. In that also we have done the question, that previous question we have done of Monday. So in Monday, that in that word no letter were repeating, but here in this word Mississippi some letters are repeating. So we have to use a different method to find out the number of permutation or total number of ways or total number of words. We have to use a different fundamental. The fundamental is given over here. As you can see, in beginning of the topic it is given total number of ways to arrange an object where P object of one kind, Q of second kind and R of third kind, and so on. Then total number of ways are factorial n upon factorial P into factorial Q into factorial R, means n will be the total number of letters over here. So in the word Mississippi, how many letters are there? If we count, see, M-I-S-S 4, again I-S-S-I, again 4, and then plus 3, means it will be total 11 letters are given to us. So we can say that the value of n in the formula is 11, and P, Q and R are the number of repetition of the letters they are repeating. For example, if we take the I first, okay, I is repeating 4 times, so I can take the value of small p as 4. Similarly, then you can see the letter S is repeating again 4 times, so value of Q I can take 4, and R is equal to 2, where P is repeating 2 times. Okay. Now one thing should be very clear, each and every time 3 letters will not be repeating. It can increase or it can decrease also. Means, for example, in some other word maybe 2 letters are only repeating, so we shall write down the number of repetition only for that 2 letters. It may possible in some word more than 3 letters are repeating. So this formula can change according to the number of repetition of the letters are given to us. So sometimes it can come as PQ only, and sometimes it can come factorial P, factorial Q, factorial R and factorial S can also come. Okay. So depending upon the number of repetition of the letter, we can change the formula accordingly. This formula is given for the 3 letters are repeating over there. Now see what they want to say. Word is given to us, in the word some letters are repeating, okay. Now in general, if I want to find out how many total words I can make with the help of the letter of the word given over there Mississippi, then I will use this formula. Now remember, here repetition is allowed and repetition is not allowed, that condition will not be possible, okay, because already the letters itself are given in the repetition mode. So automatically we can say that yes, repetition may be allowed over there, or such kind of criteria will not work in this kind of question. So now if I want to find out the total number of words, that I can find out with the help of formula factorial n upon factorial P, factorial Q and factorial R. But here they are adding some more conditions. Do the 4I not come together? Means that all the i's are given, they should not come all together. Now see, first of all try to understand how we shall solve this question, because see, directly of some question solution could not be found. It is not possible. They are asking over here that I should not come together, and directly we find out such kind of words how many are there where I doesn't come together, then it is not possible for us. Okay, we have to use some indirect method. For example, remember last year we have proved that root 2 is irrational, root 3 is irrational. Okay, so we have used a method of contradiction. So here also we shall use such kind of similar kind of method. Okay, see how we can use it. First of all, see, if I say I am finding here total number of words, total number of words, that if I am finding it. So in that total number of words, if I can categorize into two parts, one part and second part. Suppose if in major, if I want to categorize into two parts, I can say that the first part is where eyes are together, and the second part is where all the eyes are not together, right? That is possible because if I want to categorize into two parts, see in your class also we can categorize into two parts. How many persons are liking one particular game and how many persons are not liking that particular game. We can categorize. It is our criteria, what criteria we are going to follow. So here also the criteria we are going to follow, eyes are together and eyes are not together. So you should be on any one side, either the all the eyes are coming together, that is one category, and second category is all the eyes are not coming together. Okay, there are many categories we can make, but right now we are making two categories. Now if I want to find out eyes are not together, this is required for us. Okay, eyes are not together, that we want to find out. So if this one is required, how we can find out? One thing you observe, if I add the number of permutation where eyes are coming together and the number of permutation where eyes are not together, it will be equal to the total number of words. Means I can say that the total number of words will be equal to where eyes are together, okay, plus eyes are not together, that I am writing by NT. So eyes are not together. Okay, now this one is required, eyes are not together, this is a required thing. So if this eyes are together, I send on to that side, means where the total number of words are lies. So I can say that eyes are not together, that will be equal to total number of words minus eyes are together, that we can say, right? So here to find out where the eyes are not together, we can use the fundamental, from the total number of words we shall subtract wherever the eyes are coming together. You can understand this one also with the help of one small example. I will give you one more example about this, then we can start the question. See, suppose if I ask you, in a class there are total 50 students. Okay, total 50 students are given to us. So in that, out of 50 students, suppose if I say 30 are pass, how many are failed? Okay, we are not talking about the compartment examination, so don't think like that in a different manner. Okay, either a student can be a pass or it can be a fail. So suppose out of 50, 30 are pass, how many are failed? You say definitely 20. How did you find out? From 50 you subtracted 30, means from the total number of students you subtracted the number of students those who are passed. Okay, so same condition here also we are applying. From total number of words whichever we are going to form, we are subtracting the number of words where the eyes are coming together. So we shall get the number of words where the eyes are not coming together. Okay, so let us see how we can find out the solution of this question. First of all, see what I am writing here. First we shall find out the total number of words in general, means how many total words we can form with the help of the letter of the word given to us. Okay, so let us see. First we shall write down in the solution total number of letters is equal to 11, okay, including the repeating letters. In that which letters are repeating here? I, comma S and P are repeating. They are repeating. How many times they are repeating? See, I and S are repeating 4 and 4 times, and P is repeating 2 times. Okay, so 4 comma 4 comma 2 times they are repeating. Right, now further see, here we shall find out the total number of words. So we can say that therefore total number of words, total number of words is equal to, now I am using this formula, factorial n upon factorial p into factorial q into factorial r. See, n, what is n here? That is 11, factorial 11 upon factorial p means the number of repetition of any one letter, that we can say 4. I am taking I here. Then similarly I can take the second one as again 4 because S is also repeating 4 times, and the third one I can take 2 because P is repeating 2 times. So this will be a total number of words we can got here. Now this I am keeping as it is. We are finding now the total number of words where the I's are coming together. So that will mention here. Now we shall find number of words where I's are together. Okay, all the I's are together, that we are going to find. Now first of all I will show you the arrangement, how that arrangement will look. I will show you one sample that how it will look when all the I's will be together. Okay, we know that total 11 letters are there. So here for example I will make this 11 places. Remember, this is not a part of your ideal solution, so you can avoid it of making such kind of places in the examination. Okay, I am just making you to clear about the arrangement how it will look, then it will be easier for us to find out the required number of words. How many 6 are there, moreover 5 required, 1 2 3 4 and 5. Okay, now suppose that all the I's are coming together and they are coming from place number 3rd. So 1 I, second I, third I and 4 I. Okay, they all are coming together. Now we shall write down P also. 1 P is coming here and suppose 1 P is coming here. P may also come together, that doesn't matter. We are not talking about P's are coming together or not, they may come. Okay, so here for example just I am writing separately. Now the one more letter is repeating 4 times, that is S. So suppose 1 S I am writing here, 1 I am writing here, 1 I am writing along with that only, and 1 I am writing at the last. And here I am writing one letter, that is remaining M. Okay, now wherever this 4 I's will go, they all will go together. Right now they are starting with the place number 3rd. If they start with the place number 4, then 4, 5, 6, 7, that way they will occupy. They may start with the place number 8. So 8, 9, 10, 11, they will occupy in such manner. Okay, you can assume the one group of the student is sitting. So they are sitting all together. Suppose they are going to watch the movie in the theater. So they are sitting in a row, right? So in that particular row they are sitting all together. So suppose if you say you shift to some other place, so they all 4 students will be shifted together. So wherever they will go all together. So here we can say that these 4 students, 4 friends or 4 I's are forming one particular group. Okay, because they all are going together. So this 4 students, 4 I's are making one group, and this one group we can assume as one particular place. that only the thing is need to understand in this question, otherwise the question is nothing. That is the main thing. Okay, this particular thing we shall assume as one place, because now they have clubbed all the i's. Okay, wherever they are going all together, so we can assume that is the one place. Okay, and now total number of places will be also reduced, that all 4 places are clubbed to one place. So we can say that my total number of places will be 1, 2, then this one is 3, this clubbed place I am supposing 3, then 4, 5, 6, 7, and this one is 8. So I can say that here the total number of places will be equal to 8. I have to arrange only 8 places. I don't want to arrange the more than 8 places. The clubbed place 3 can shift to 4. So in that case 4, 5, 6, 7 they will occupy. But again 4, 5, 6, 7 we shall assume the place number 4th. And accordingly if we count, the total number of places will come always 8 only. Okay, so here we can see that now my places has reduced, that will become 8. So here first thing I will mention, therefore in this case total number of places is equal to 8. In that, now we need to find out in that who is repeating, because the earlier we found the general permutation, then total number of places were 11, then we found who are repeating letters, then we use the formula factorial n upon factorial p into factorial q into factorial r. So here now who is repeating? Remember, this all 4 i's are one letter now. Okay, so that we are not counting as a repeating letter, that is one group for us, one place only. Okay, so now if we leave the I, S is repeating now also, P is repeating also 2 times. So we can say that S comma P are repeating 4, 2 times. Okay, therefore we can say that number of words where i's are together, that now we are finding it, i's are together is equal to, now formula I am using same, factorial n upon factorial p into factorial q. Only 2 letters are repeating, so I am not talking about r. So what is the value of n here? Value of n is factorial 8 upon factorial p is factorial 4 into factorial 2. Okay, so now see, we found the number of words where i's are together. So now at last we shall write down, therefore number of words that I have explained in the beginning, number of words where i's are not together, i's are not together is equal to total number of words subtracted the number of words where i's are together, that I have told you in the beginning only. Okay, so here we can say that if we subtract in this manner, we will get the required answer. Now total number of words, what we got there, factorial 11 upon factorial 4 into factorial 4 into factorial 2. Okay, minus the number of words we got where i's are together, factorial 8 upon factorial 4 into factorial 2. Now let us simplify. So here 11 I will open till 8 first. Okay, I am taking some letters common. So if some factorials can be common, it will be easier for us. So see how I am simplifying. 11 I am going to open till 8 first. 11 into 10 into 9 and then into factorial 8. Till that only I am keeping. I can open factorial 8 also, but 8 I am keeping in the factorial. Then 1 factorial 4 I am going to open. 4 into 3 into 2 into 1 into factorial 4 into factorial 2, that I am keeping as it is, and this whole term also I am keeping as it is, factorial 8, 4 and 2. Now here 4, 2 2s are 4, 2 5s are 10, that we can cancel. Okay, again 3 1s are 3 and 3 3s are 9, we can cancel. Anything else we can cancel? No. So here one thing you observe, factorial 8, factorial 4 and factorial 2 you observe that is common. So first of all we can take factorial 8 upon factorial 4 into factorial 2 common. What is remaining here? If we have cancelled 10 and 4, so remaining is 5. So 11 into 15, that will be I think 165. So 165 upon 2 into 2 4. Okay, and then minus 1 will remain because at the second place the whole 8, 4 and 2 we have taken common, right? 11 into 15, yes, that will be 165. So now we will take the LCM over here. So factorial 8 upon factorial 4 into factorial 2 into the bracket. If we take the LCM and simplify, that will come 161 upon 4, because 165 we shall subtract the 4. Now we need to open. Okay, we do not have any option, so we shall open up now. So factorial 8 will open till factorial 4. So 8 into 7 into 6 into 5. Okay, and into factorial 4 I am keeping as it is, upon factorial 4 will be as it is, into factorial 2 is 2 only, and 161 upon 4. So see, this factorial 4 and factorial 4 is cancelled, 2 and 4 became 8, and this 8 also we have cancelled. So now what is remaining? 7 into 6 into 5. 6 into 5 we can write down 30, and 7 and 161 we can multiply. 7 1 is 7, 7 6 are 42, 2 carry 4, and 7 1 is 7 plus 4, that will be 1127 I suppose. Okay, please see if any calculation mistake is there. Once again we can multiply. 7 1 is 7, 7 6 are 42, 2 carry 4, 7 1 is 7 plus 4 11. Now let us multiply for the final time. 0 will come, 7 3 is 21, 1 carry 2, 3 2 is 6 plus 2 8, and then 3 1s are 3, 3 1s are 3. So we can say that therefore total number of words, where eyes are not together, eyes are not together are 33810. Okay, so this complete our question. Let us see now question number 10th. In the question number 10th, see, we have given that, yes, question number 10th, in how many ways can the letter of the word permutations be arranged if the word start with P and with S? Vowels are all together and there are always 4 letters between P and S. Okay, let us see one by one all the 3 parts. These questions are lengthy, so we may not be able to finish the more questions today. Okay, let us see now 11th question, first part. First of all, see, in the letter of the word permutation, is any letter is repeating? Definitely yes, because you see T is repeating there 2 times, so we cannot use the formula NPR Okay, we need to use the formula same we used in the previous question. Okay, nowhere the formula of NPR can be used. So first of all, in this we shall write down the total number of letters. So how many total number of letters we have? Total number of letters is equal to, we shall count PER 3, MUT 6 plus 2 8 10 12. I think we are getting the total number of letters are 12. In that, what we shall write down? In that T is repeating 2 times. Only T is repeating, right? You can observe there is no other letter is repeating more than once. T is repeating 2 times, that we have mentioned. Now let us start the first part. We can find out the general words also with the help of that, but since they are not asking the general permutations, means they are not asking the total number of letters with the help of the letter of the word permutations. Okay, so we shall focus only on the first part. In the first part, what they are saying? Word start with P and end with S. Okay, means word should start with P and it should be ending with the S, as the permutation word is starting. You see, the permutation word in that P is starting with P and ending with S. So here, if I show you such kind of permutation, so I will make here first of all 12 places. How many I have made? 3, 5, 8 and 4 more. See, total 12 places I have taken here. Now what they are asking, the letters start with P and end with S. Okay, so here one thing you observe, the first place and second place we need not to arrange because that is now fixed. These 2 places are fixed over here, so that 2 places we need not to arrange. Okay, that will not take in the part of the finding the total number of letters. These are fixed places. Okay, you remember we have solved one question in the previous exercise, or maybe in this only, I don't remember, but that in that question it was given to us like that the mobile number they were going to form, and the mobile number starting with the specific 2 digit, I think one is 6 and second one is 5. Okay, then we have to arrange the remaining places over there. So we thought about the only remaining places permutation because the first 2 places were reserved and that numbers also we could not use in the remaining places or given to us. Here also we are not using the P and S in the remaining places. Okay, now you see how many letters are remaining. So we can say that here, if word start with P, and end with S, then in this case total number of letters now what will remain? So we can say that in this case total number of letters is equal to 10, because earlier we have given that total number of letters are 12, but since now 2 letters are reserved in the beginning and ending, so total number of letters are remaining here 10. We can say that, and in that 10 letters, is there any letter is repeating? Definitely yes, because in that 10 letters again we can say that T is repeating 10 times. Sorry, T is repeating 2 times. Okay, so now we can find out the total number of words as per the condition 1. So therefore total number of words, again the formula can't be used here, NPR. We are going to use the formula here, factorial n, upon factorial p into factorial q into factorial r. Okay, so here the value of n is 10, that is factorial 10 upon, since only one letter is repeating, so we shall put up the value of p, and q and r we shall keep it as it is. Now solving will take time, so we shall not waste our time in solving the given permutation over there, that we can solve it little later. We can focus now on to the second part. In the second part, see what they are saying, vowels are all together. So let us see now part number second. Part number second, they are saying vowels are all together. I will show you again such kind of permutation. One sample I will show you, then only you will understand. Okay, see, once again I will make here 12 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, now see, in the given letter permutation, how many vowels we have given? If we talk about the vowels, then who are the vowels given to us? See, letter we have given there, permutation, P-E-R-M-U-T-A-T-I-O-N-S. Okay, 1, 2, 3, 4, 5, 6, 7, 9 plus 3, 12. Now in this, who are the vowels? Suppose if we talk about the vowels, then one is E, second one is U, then A, then I and then O. Unique word where all the 5 vowels are coming and they are coming only one time. And if we talk about the consonant or the remaining letters, so consonants will be here P, then R, then M, then T, then who is remaining, T is coming 2 times, and then N and S. Okay, 1, 2, 3, 4, 5, 6, 7. 7 consonant and 5 vowels. Total number of letters are here 12. Now see what they are saying, vowels are all together. Now link this part with the previous question where all the eyes were coming to not together, but we found first all the eyes are coming together. So here our job is just to find out in the same way as we found all the eyes are together, we shall find out the number of words where all the vowels are coming together. Okay, so see, suppose if I say vowels are starting with the place E, U, A, I and then O. They are forming their one group. Wherever they are going, E, U, A, I, O means these 5 vowels will go at all together, they will go at the same place. Okay, and here suppose it is coming P, then T is coming, then here it is coming R. Okay, again T I can take, and then I can take M and S. Okay, this will be my first place, second place, this will be my one place, I can say total this will be the third place, fourth, fifth, sixth, seventh and eighth. Again total number of places are 8 because that 5 are clubbed into one place. Okay, so the 5 has become 1 and remaining 7 places, so total are here 8 places. Now here if I ask you, now observe, we are doing it exactly in the same manner. We are using the formula factorial n upon factorial p, factorial q, factorial r. So total number of letters are here 8, so it will be factorial 8. Okay, upon, then we shall write down the number of letters as they are repeating that many times. So only one letter is there who is repeating, that is 2. Sorry, that is T 2 times. So factorial 2 will come. This is your answer. But this answer is little incomplete. Means here I can say that factorial 8 upon factorial 2 is giving you where all the vowels are coming together, but there is one only small mistake over there. See, in the previous question where all the i's were coming together, so internally if they are changing the places, the arrangement will look same only. Means, for example, suppose if I show you, look at this one. Suppose if I show you the previous question, look at over here. Observe here all the i's are same, they are identical. So if second I is going on to the first I, means suppose if I mark this is first I, second I, third I, and this is fourth I. Okay. However, since they are same, when you will see, you will not find out which is first and which is second. But suppose if I marked second I is going on to the first place, first I is going on to the fourth place, then also the arrangement will look same only, because all the i's are identical. They may be changing the places internally. As I told you, 4 friends are sitting together, but it doesn't mean that from the beginning of the movie till the end they will sit at the same places. They are sitting together, but internally they can change the places. The friend who is sitting at the corner may come in the middle, those who are sitting in the middle may go in the corner. That may possible. Same way the things will happen here, and here if the things are happening in the same manner, then the arrangement will not look same as compared to the previous question. Okay, so here U is coming at the place of E, E is going at the place of I, and same way the other letters are changing the places, then your word will look different. Okay, so here we need to find out the number of arrangement for these 5 letters. Now if we talk about these 5 letters, there is no letter is repeating. Okay, so how many total letters we are giving? Remember, I am talking about these 5 vowels only, right? So these 5 vowels, how many total number of letters we have? 5. How many places we need to arrange? Because that 5 letters are sitting onto the 5 places. So number of places I need to arrange here? 5. Here I will use the formula NPR. So their arrangement will become 5P5. And remember, still now the process is not completed. Since it is a part of the process, so I will multiply it with 5P5. Okay, remember here multiplication would be done, because factorial 8 upon factorial 2 is a part of the process and 5P5 is the another part of the process. So as you assemble the things, 1 part, 2 part, 3 part, same way we are also here assembling, but while assembling we are multiplying. Okay, and whenever the different cases we shall consider, we shall add it. That will come further. Okay, we shall talk about later, but right now remember, if one part you are finding it with the help of one way, another way part you are finding it with the help of another way, while assembling both the parts you have to multiply. Okay, so here one thing remember, if the vowels are changing the places internally, then the whole word will look different. Sequence matter here. Okay, so in that case we have to find out the internal arrangement for the vowel as well. Now let us see how we shall express the answer over here. So therefore what we can write down here? Total number of letters, total number of letters. Okay, as per the counting I have shown you, the total number of letters are equal to here 8. Okay, and in that who is repeating? In that T is repeating 2 times. In that we can say T is repeating, T is repeating 2 times. Okay, so we can say that therefore total number of words, total number of words will be equal to. Okay, now see what is the value of factorial n here? That is now factorial 8, and in that 8 letters T is repeating 2 times, so value of factorial P we can write down here as factorial 2. So now you may say that we got the answer, but this is an incomplete answer. Why? I will tell you. See, in the previous question when we have supposed all the 4 i's were coming together, So if all the four i's internally changing the places, since they were identical, so the whole word looks same only. For example, if this all a's are only coming here a and all the remaining four places are also occupied by a. So if they are changing the places, then the internal arrangement will not change. This factorial 8 upon factorial 2 shows the outer arrangement, means this group is going on to the other place, means suppose it is staying right now at the fourth place, it may be going at the fifth place, sixth place, or these letters M, T, N, S, maybe they are changing their places, so it is showing that kind of arrangement. But for the internal arrangement where the vowels can change the places over there, that arrangement we did not include. Okay, in the previous one, since eyes were same, that's why the arrangement were looking same, but here if the vowels change the places, the word will look definitely different. So here we shall see that internal arrangement, and remember this is the arrangement for this particular place. So remaining places arrangement and this particular place arrangement, if we have, so according to the fundamental principle of counting, we can say that both the arrangement we shall multiply. Okay, so here first of all we shall put a sign of multiplication, and now see how many places we have. 1 2 3 4 5. At this 5 places how many letters can come? 5 letters can come. In this 5 letters, can we say that any letter is repeating? No. A, E, I, O, U are coming at one place only, and they are single letters. Nobody is repeating. So we can say that their arrangement will be here 5P5. We shall use the formula NPR. NPR will be utilized where repetition is not there, means letters are not repeating. So now you can simplify this one and you can get the answer. For example, factorial 8, if I simplify, 8 into 7 into 6 into 5 into 4 into 3 into 2 upon factorial 2 is there. Okay, and into 5p5, that is factorial 5, upon 5 minus 5, that is factorial 0. NPR formula we are using it here. Now 2 and this 2 we can cancel, so here it will remain 8 into, I think 720, sorry, 8 into 7 and then till 6. 6 into 5 30, 30 into 4 120, 120 into 3 360. So it will remain 360, and factorial 5, that is 120. Factorial 0, that is 1. So finally we need to multiply 56 into 360 into 120. So that multiplication you can do it, or I will solve it at the last. Okay. So this multiplication I am leaving, we can do it afterwards. Now quickly we shall go for part number 3rd, because I told you these questions are very long, so it will take some time. Now look at the condition of 3rd part. In the 3rd part, what we have given, there are always 4 letters between P and S. Means wherever the P and S you place, but you keep a gap of 4 letters between P and S. Let us see how this kind of combination can be done. Okay, so first we shall write down the condition. What condition this set to us? The condition this set, I am keeping some space for the remaining calculation. So here 4 letters, 4 letters required between P and S. I will show you one arrangement of this kind. Okay, again for that I need the 12 places. So 1 2 3 4 5 6 7 8 9 10 11 and then 12. Now see, here if I place P at the first place, okay, so I need to keep a gap of 4 places and then S will come. So 1 2 3 and 4, and then here I can keep S over there. This is one arrangement. Okay, means one way. Suppose if I keep P at the second place, then definitely S will come here. Suppose I keep the P at the third place, then S will come at here. Similarly, P I am keeping at the fourth place, then S will come here. P I am keeping at the place number 5, then definitely S will be coming here. Suppose P I am keeping at the 6th place. Okay, so definitely the S will be coming at this place. Again P I am keeping at the 7th place, then S will be coming at the 8th, that last place. So this is the one arrangement can be done. Okay, P I have started from P and ending with S. So if P I am keeping at the first place, accordingly S will be coming on the place number 6. Okay, that we can say, and accordingly we form the arrangement. Now how many these arrangements are there? Count it. 1, 2, 3, 4, 5, 6 and 7. Means by 7 ways I can arrange where P is coming in the beginning and after 4 places S is coming, right? Now we can say that if P comes in beginning and S comes after 4 places, then this we can arrange, this we can arrange. Remember, I am just arranging the P and S over here. This we can arrange by 7 ways. Similarly, see, here they didn't say that P should come in the beginning and S should come after the 4 places. So we can say that similarly, if S come in the beginning, similarly, S comes in beginning, S comes in beginning and P comes after 4 places. P comes after 4 places, then this can be also arranged by 7 ways. Only letters are interchanging, arrangement will same, right? This can be arranged by 7 ways. So we can say that therefore letter P and S, with a gap of 4 places, gap of 4 places could be arranged by, could be arranged by could be arranged by 7 plus 7, that we will add is equal to 14 ways. Okay, first we are counting first 7 where P is coming in the front, S is coming at the last. Again we are counting, now S is coming in the beginning and P is coming at the last. So total number of ways will be here 14. Remember this ways only I have shown for P and S. Now P and S I am keeping, some places are vacant over there and some more places are vacant after P and S. Okay, so how many places are remaining after that? So we can say that and for remaining places, and for remaining places what we can say, remaining places we can say total letters, total number of letters, total number of letters that is remaining here 10, and in that again, in that T is T is coming 2 times. Again T is coming there, right? So T is coming here 2 times. So we can say that therefore total number of words of this kind, total number of words of this kind where P and S keeping 4 letters between them is equal to factorial 10. First of all, we shall see for the remaining letters upon factorial 2 and the arrangement for P and S. That's why multiplication is coming. It is a part of the total arrangement. Okay. So we are putting the multiplication sign that will be multiplied by 14. So here that we can simplify and we can get the answer over there. This simplification I will do it separately and in the notes I will send you over there. Okay, so this we can keep it separately and we can solve it afterwards. So this question is completed. Next time we will see the exercise 7.4 onwards. Okay, thank you.